Hello, today we are doing Chapter 5, Section 3, and our essential question is how to use elimination to solve a system of linear equations. Well, here's kind of a go-to guide. I would suggest you hit pause, write these steps down, watch a couple of the examples, go back and revisit these examples or this core concept. If it does not make more sense after seeing a couple examples, you probably need to watch some other examples as well. Go ahead and get on Google, type solving systems equations by elimination. There's going to be a ton of example problems out there. It's kind of up to you to search some of them. This video is only going to be 10 to 15 minutes, so we can only do so many examples. So on our first example, what I notice right away is I already have opposite coefficients, positive 2, negative 2. When you add those together, they become 0. So I'm just going to cross them out. You might say, well, 4, negative 4 is 0. Why didn't we cross them out? Well, we need to have something written down on that right-hand side of the equal sign, so you have to write that 0. Divide both sides by 6, and you get x equals 0. Well, that tells us half the answer. We need to know our y. It doesn't matter which one you go to. You can go for equation 1 or 2, plug 0 in for x, solve for y. Well, 3 times 0 is 0. Then you divide both sides by 2. Y is 2. Our solution is 0, 2. And again, I'm talking pretty quick and going through these examples. Feel free to pause. On our next example, negative 10x plus 3y equals 1, and negative 5x plus minus 6y equals negative 23. We need to have opposite coefficients. So what I notice right here is I have negative 10. Negative 10. The opposite of negative 10 is positive 10. So I need to create positive 10 right there. So what times negative 5 is going to give me positive 10? Well, that's negative 2. That's why I'm going to be multiplying both sides by that equation by negative 2. So I will a lot of times even just write it down like that. Negative 2. And I put parentheses around the whole thing because you need to do the left-hand side and the right-hand side. And if you notice, we now have opposite coefficients. Positive 10, negative 10. Because when we add those together, they cancel each other out. Add the equations together. My x's are eliminated. 3y plus 12y equals 15. 1 plus negative 46 equals negative 45. Divide both sides by 15. And you get y equals negative 3. Yeah, that's great. That tells me my y. I need to find my x. So my last step is I have to go back to one of the original equations. Again, it doesn't matter which one. Looks like I'm going to go with equation number 2. I'm going to take out that y, put in negative 3. So I get negative 5x plus 18 equals 23. Subtract 18. Divide by negative 5. And I get x equals negative 1. So my solution is negative 1, negative 3. All right. I'm going to get you started a little bit on these and then ask you to hit pause and try them on your own. So on this one, you already have opposite coefficients, positive 3, negative 3. So you can go ahead and just add those two equations together and eliminate those x's. On this one, we don't have anything that's opposite, or no opposite coefficients. I have a negative 3 right here. The opposite of negative 3 is positive 3. So I'm going to multiply this bottom equation by 3. Here, I've got x and a positive 4, positive 4y, and a positive y. Let's go ahead and multiply that top equation by negative 4, because that'll give me negative 4x, which is the opposite of positive 4x. So, got you started on these? Go ahead and hit pause. Check your answer. And again, you should always be able to verify that you have the correct answer by plugging in x equals 1, y equals 2 into both equations, and it should work out. All right, let's go ahead and do a word problem. A business with 2 locations buys 7 large delivery vans and 5 small delivery vans. Location A receives 5 large vans and 2 small vans for a total cost of $235,000. Location B receives 2 large vans and 3 small vans for a total cost of $160,000. What is the cost of each type of van? All right, that last question is really the most important. We have 2 vans, a small and a large. We need to know the type of each. They give us 2 scenarios, so in my plan, I'm going to write 2 equations. So let's go ahead and solve that. 5 times the cost of a large van plus 2 times the cost of a small van equals 235. Do the same thing for your second equation. And again, it doesn't matter what you choose your variables to be. Right now, we're going to let x be the large and y be the small. Whoops, just a second. It sounds like a phone is going off. All right, sorry about that. I hit pause for a second. So x is going to be the cost of the large, and y is the cost of the small. So let's go ahead and get our equations. 5x plus 2y equals 235. 2x plus 3y equals 160,000. Well, we don't have any opposite coefficients here. So I'm going to multiply equation number 1 by negative 3. And that creates a negative 6y. So that means I need to multiply the bottom one by 2. So I'm creating opposite coefficients here. Negative 6y, positive 6y. If I wanted to, I could have eliminated my x's, multiplied the top one by negative 2 and the bottom one by 5. So go ahead and do your multiplication. Rewrite both of those equations down. My y's will eliminate. Negative 15 plus 4 gives me a negative 11x. My y's cancel. Go ahead and add those 2 numbers together. You might want to use your calculator. Then divide by negative 11. And you get x equals 35,000. And that's the price of the large van. That seems reasonable. So I'm thinking that I'm in good shape. Let's go ahead and find the price of the small van. So I can plug that back into one of the original equations. Looks like I'm going with equation number 1. So it's going to be 70,000 plus 2y equals 235. Subtract 70,000, divide by 2, and you get 30,000. So large van is 35,000, small van is 30,000. And both of those answers do make sense. All right, we're actually going to go ahead and stop right there. Hope you enjoyed.